Good morning, guys. Welcome to our second video on density. In our first video, we decided that density was a measure of how crowded or tightly packed the matter, meaning the atoms, in an object or a substance is. We also talked about we could look at the atoms and see how much empty space is in between them to decide how dense something is. If we have a lot of empty space between the atoms, we might say that that substance or that object is less dense, or it has a low density. If we look and see very little empty space between the atoms, then we're probably going to decide that it is a more dense or a high density substance or object. In addition, in our first video, we also learned that the formula for calculating density is equal to mass divided by volume. So that's mass divided by volume. Mass, of course, being a property of matter that we've studied already, which was the amount of matter that something contains, whereas volume is just how much space that matter takes up. So I really wanted to take a look with you this morning at also a simulation that we've seen in the past, and I'm going to start out with some water molecules. So we have some water molecules in a container, and we have those water molecules, of course, moving. We never have molecules or atoms that have no energy and are completely still. But I want to go ahead and put some extra molecules in there. So you can see that just by using this pump on the right-hand side of the screen, then I'm able to add more matter. Now, if I'm adding more matter, that automatically means that I am increasing the density. So when I increase mass, and the more matter that I add in there, think about it, the more crowded it's going to be. And the more crowded I make it, the less empty space there is, the more tightly packed these molecules of water become. And so I make the substance in this container be more dense. And I could keep doing that. I could just keep adding matter, and it would get more dense, and even more dense, and even more dense based on the amount of matter that I'm adding. Now, there is a second way that I could increase the density, and this way does not actually require me to add more matter. But if I could change the amount, of space that matter had to be in, that is also going to raise our density, because once again, if I decrease the amount of space, I'm making it more crowded. And so just by changing the size of the container, and I can make it smaller and smaller, and you can see that these these molecules of water, they get more energetic when I do this. This adds something called more pressure. But the key part here is, if I want to increase density, there's two ways I can do it. I can either add more matter, so I can add matter, and when I add more matter, more atoms, that's going to make things more tightly packed, or I can decrease volume. So either one of those is a way to go ahead and increase density or make something have a higher density. Now, we could also decrease density, and to decrease density, I'm going to go ahead and I'm going to do something here where I'm going to go ahead and explode our container. We had too much energy in those molecules, but what I would like to do now is I'm going to return the lid back on the container, and you'll notice that I have fewer atoms in there now. So I have once again increased the space on the amount of space in the container, and I've also increased the amount of matter. By doing that, I have also decreased the density. So I'll leave a link to this simulation online, and you guys can check it out there. Thanks for listening.